This is from last class. We're just kind of reminding people, right, so this is kind of how it works initially. Right, so initially, that means in the beginning, when x is 0, your y, the quantity, was 87. So when x was 0, y was 87. That's your c. Your c is what y is when x is 0.
Wait, where is it?
Your initial amount. This is I think it was a previous, I think it was a previous one maybe.
Oh, okay.
So then you know that your c is 87. So then you have y equals 87 times a to the x. So then you find the other point. We're always going to give you some other point. After 6 years, the quantity is 14. So that means after 6 years, when x is 6, the quantity, the y, is 14. That's where you get your second point, 6 comma 14. So once you find your initial amount, and you know your c, then you can plug the other point in for x and y. So x is 6, y is 14. And then you need to solve that. So how do you solve that? First, you need to get your exponent by itself, which means you need to divide out the stuff in parentheses by itself. You need to get rid of the 87. How to get rid of the 87? Divide both sides by 87. So I did that above. So I had a to the 6th equals 0.1609. And then remember, that's the tricky one. I have a to the 6th. I want a to the 1. So it means I need to raise both sides to the 1/6 power, because it's a to the 6th. So raising both sides to the 1/6 power will make it a to the 1. So that's why we had to do 0.1609 to the 1/6 power. We kind of went over different ways of doing that one. So that's where we got a is 0.737. So then now you have your whole part. C is 87, a is 0.737. That's your model. So this was kind of the harder example. I wanted to review with folks so that you remembered that, because it's important to kind of refresh our memories on all this.
Yeah, that one was a difficult one.
Yeah, that one was a little bit tougher. So let's take a look at the ones we have here. So here, we did this first one already, so I guess we won't do that one again. But we did do this one. All right. Sample of 5,000 bacteria decreases exponentially by 25% per week. That means that this is it decreases, so I'm going to subtract 25%. So that means that my A is 100% minus 25%. So that's 75%. What's 75% as a decimal? How much is 75%? 75 cents. How do I write 75 cents?
0.75.
0.75. Okay, and then what's my initial amount?
5,000.
Sample of 5,000 bacteria. That's my C, my initial amount. Right? So C, your initial amount, equals 5,000. So then I have my formula. Y equals my initial amount, C, 5,000, times something to the x power, a to the x power. A is 0.75. Good. Now we need to interpret f of 4. So this means when x is 4, right? So put 4 in for x. We'll have y equals 5,000 times 0.75 to the 4th power. So what did you all get for that?
1,582.03.
0.03?
Yeah.
Okay, so let's round it off to the nearest bacteria. And that seems reasonable. Good. So that seems like a reasonable amount. Okay, so next one, in the world of investments, compounding refers to the practice of calculating the interest earned on investments and then adding the interest to the amount invested. So here we have $1,200. What's that? Yeah, my initial amount. So this is my initial amount. And then, this is my rate. I'm increasing. It's going to grow. So it means this is my rate of increase. So it means that my growth factor will be 100%, that's what I start with, but then I gain 4.5% each year, so that's 104.5%. How to write 104 cents? $1.04, 1.04, and then just add the 5 at the end. So that's my A. Everybody all right with that part? Good, so then I just pop that in. So I have y equals my C, 1200, times my A, 1.045, to the x. Great. So the growth factor was 1.045. This is part D. And then how much money will be there after 10 years? So we're going to pop in 10 for this. So here's C, y equals 1200 times 1.045 to the 10th power. And again, work from the inside out. So that's 1200 times 1.045 to the 10th power. 1.045 to the 10th. I got 1.55293. Okay, so give yourself at least 4 significant digits. At least 4 or 5. So significant digits means share the first one that's not 0, and then you kind of go over 1, 2, 3, 4. We covered that our first week, significant digits. And then I'm going to multiply that by 1200, and I end up with $1,863.56. Good.
For sig figs, you just look at the smallest sig figs in the problem, and then you take it out to that point?
Actually, for these, I would just always go like at least, the general rule is you want at least 3 sig figs. So I would say for these, I might go 4, just to be on the safe side.
Mm-hmm.
Doesn't hurt you.
Okay.
Yeah. Okay. And then we did not do this one, so let's take a look at this one. Number 4. Have people finished 4?
Yeah.
Yeah, we'll take a look at 4. Oops, not that. Okay, so peak level is 0.07, so that's my starting amount, right? It's my initial amount. So it means that C is equal to 0.07, okay? Good. Decreases by 40%. So that means that 100% minus 40%, 60%, and as a decimal, that's 60 cents, 0.60. Right, so percent, to change from percent to decimal, just think of that as being cents. 60% is 60 cents. How to write 60 cents? 0.60.
Would it matter if you didn't use a 0? You just go 0.6?
You can just do 0.6 as well, that's
Okay.
fine. Either one, right, 0.6 or 0.60. I'm writing a exponential function that models it. Okay, that's pretty straightforward now, right? B, y equals, I know my C, 0.07, I know my A, 0.6, to the x. Done. How easy is that, right? We've given you the initial amount. You've sorted out what the growth factor or decay factor is. Done. Okay, and then last, interpret B of 2. So here's C, y equals 0.07 times 0.6 to the second power. Right, because it's b of 2.
Mhm.
And what did you all get for that? So it's 0.07 times 0.6 to the second power. 0.00, what,
Because, 0.0252.
252? Okay, that seems reasonable. Oh, then we have to interpret it. Ooh, interpret it. What does that mean? What does that mean? Does that mean that,
After 2 hours, her blood alcohol level dropped to 0.52%.
great, so 2 represents hours. So after 2 hours. And then Y represents your blood alcohol level. Perfect. It's going to be important that you be able to interpret that. After 2 hours, the blood alcohol level is 0.0252. I forgot to do that in the last one. Let's look at the last one. Did they ask us to interpret this one? No, they said how much money will be in the account. Okay.
Oh, 2 is interpreted.
What was that?
1 and 2 we're supposed to interpret.
Oh, we're supposed to interpret 1 and 2. Sorry, my bad. So number 1, right, we are supposed to interpret this one. So what does it mean? F of 4. What's F of 4 mean?
4 days.
What's 4 represent?
Days.
Days or weeks? Are we doing number 1 or number 2?
Oh, which one are you doing?
Do you guys want to do 1 first or 2 first? 1? We can do 1 first. That seems reasonable. Oh, I didn't do 1. We didn't go over 1. Okay. So, number 2, well, we can do number 1. I have number 1 right here. Okay. All right, so number 1, we found our model, and then we need to interpret f of 4. 700 times 2.3 to the 4th. And what did y'all get for that? Fox, what did you get for that?
I got 19,588.87.
Great. Okay, so Gabe, what is that? How would you interpret that?
I would say after 4 days, there are 19,589 insects.
19,000, how many did you say?
589.
Yeah, okay, sounds good.
Well, we
Well,
rounded it.
0.87, so you rounded. Okay, good. And then this one here, number 2. Ryan, how would you interpret number 2?
Would be 1,582.031 after.
What, 1.5, wait, we're on number 2. There's
Yeah.
1.582. I just rounded the whole number.
Oh, okay. Bacteria after 4, would it be weeks? Or days?
Bacteria after 4 weeks. Sure. Great. Yeah, that works. You can put it either way, either direction. After 4 weeks, there are 1,582 bacteria, or vice versa. Good. Okay. So, now let's take a look at these. Linear versus exponential change. So, given a table of values for a function, it's possible to determine whether the quantity represented in the table is changing as a linear function or as a exponential function. So remember, what happens with exponential functions? As you increase, is it a growth amount or a growth factor?
Yeah.
Factor. Factor means what? Adding or multiplying? Multiplying. So we increase by multiplying each time. So if you folks remember, where was it? We really went over here. Right? We said that we didn't go by adding the same amount each time. We went by multiplying by the same amount each time. Right? Multiplied by 3, multiplied by 3, multiplied by 3. That's our multiplier, that's our growth factor right there. And that's what you're doing in the problems we've been doing recently. The same thing. Right? We're multiplying by 0.6 2 times. So that's why it went from, that's why it decreased. Every time you multiply by a number smaller than 1, it goes down. You lose 40%. So we lost 40%, we lost another 40%. Now we went from 0.07 down to 0.0252. So this is changing by multiplying by a number each time. So the question is here, are these changing by multiplying by a number each time or adding a number each time? Linear, you add or subtract a number each time. Remember that the one we did in class for linear was how many units does it cost? What's the cost of going to school? 1 unit, you pay $50. 2 units, you pay $100. 3 units, you pay $150. You pay $50 per unit or something like that. So here, as my x increases by the same amount each time, my y's, are they increasing by adding a certain amount or by multiplying by a certain amount? Adding. So everyone see this?
Mhm.
Plus 3, plus 3, plus 3. So this is by adding 3. So this is linear because you're adding 3 each time. And in fact, we can, okay, so what's my initial amount?
1/4.
1/4, when x is 0, y is 1/4. So that's my c. How much am I multiplying by each time?
4.
4 to the x. So again, this goes there. This goes there. This one here, this one goes here. Exponential, because you're multiplying. So figure out what your c is. So it's going to be y equals c times a to the x. C is your initial amount. Alex, what's my initial amount?
100.
Great. And then, Callisto, what's my multiplier? 1/2. Everybody write the formula. What should be the formula? Y equals my c, 100, times my multiplier, or my base, my growth factor, 1/2 to the x.
Is there a different way, like if you're dividing by 2?
But you could say, yeah, you could say divide by 2. So dividing by 2, that would be, again,
Oh,
take 1,
yeah.
divide by 2.
That's right. Okay.
Yeah. Okay. one we are going to Basie's a little bit tricky. Okay, so what's my initial amount? C equals what? Everyone find what my C is. From the table. Shania, what's my C? 500. Okay. And then my growth factor is going to be,
2.
well, it's sort of 2. It's 2, you end up by 2 for every, the x is going up by 50. So it's 2 over 50.
Oh,
Does that sort of make sense? So it's kind of like your slope. If it's your change in y over your change in, it's a little bit trickier.
oh, okay. Oh, so this is like linear on top and exponential on the bottom or something?
Well, your linear should, the x should always go up linearly. Yeah.
Oh,
So here, for every 50, so here, this is for every 50 minutes. It doubles. So here we write y equals 500 times 2 over 50. Oh wait, I'm sorry, that's not right. Growth factor is 2. It's 2, it doubles for every 2 minutes, so it's a little bit trickier. It's 2, but it is times x over 50, right? Yeah. So I'm not going to give you one like this. So just write that and don't worry about it. We're not going to test on that one because that just gets really messy and confusing. It doubles for every 50 minutes. We're going to skip E because we just didn't have enough time to cover it. Instead, we're going to hop into logarithmic functions. If one wants to take a quick 5-minute break, just use the bathroom, we'll come back. We'll do that.